Welcome to another GC Basic demonstration. This is part 10 for the Q20 chipset, and this is all about EEPROMs. I must apologize. The previous video was February 2024, and now it's October. I have been extremely busy working on other parts of the GC Basic toolchain, and now I've got time to return to this video chain. So what we're looking at is EEPROM, showing values from the EEPROM on a serial terminal and how that operates. Just to recap, GC Basic is a toolchain for PIC AVRs and LGTs, and it now supports the Q20 chip family, and it really simplifies the use of EEPROM. So I've got a prototype board I'm going to show you. It's powered at 5 volts. I've got a programmer. It's a PICKit2 I'll attach in, and I've got a serial port through a TTL adapter. I've got some LEDs and resistors, potentiometers, and a switch. And what does that look like? It looks like this. Here we go. It looks like this. Basically what I've got here is a prototype board. Let me just zoom out so we can see it. Here are the LEDs we spoke about. Here are some switches, a potentiometer. Here's the chip itself, the 16Q20. And all this is connected by these leads. And you can make this board yourself. It's extremely simple. It's just like, it's very simple. And if you want the details on that, drop us a note and we'll publish it. Back to the PowerPoint. But that's the board I'm going to be using. And out the top of here, you can't quite see it, I've got a serial connector and I've got a PICKit2 connected up to this board. And I'm just going to put that in there so that you can see it. It's got volts on it and the board is now operating because it had volts in it, which is great. Let's go back to my presentation. So what we're looking at is part of the memory, and the memory on this specific to this EEPROM is 256 bytes of data EEPROM. There's obviously 64K of program memory and 4K of RAM, but there's also other parts of memory, but we're focusing on this 256. And that 256 bytes is actually located at a particular area of memory but the GC Basic puts a wrap around that, so it's very much easier to use. You don't have to know those addresses. You're just going to address those as 0 to 255, which is the 256 bytes. And it's electrically erasable, programmable, read-only memory. So it's non-volatile. You turn the power off and it is retained. Now the EEPROM itself is exposed. It's exposed to you as a programmer through a constant called chip EEPROM. There are other constants available like chip words, chip RAM, and chip SAF mem words, but the one that we're looking at is chip EEPROM, and it just says what the value of that is, and that gives you an idea of what the scope is, because it could be 128, 256, or larger. And what we're going to look at is EEPROM 4 ways. You can do this 4 ways. The one that I haven't shown on the screen here is you can just poke things into memory. Well, so therefore, it is 4 ways, but you can actually do it we'll show you 3. So what we're going to look at is this one here on the right-hand side. I'll bring my pointer up, my pen. This one here initially, and that initial one there, within there, is a function called a method called EPWrite and EPRead, and what we're going to do is write some data out and then read it back in, which is really simple, and that's the one we're going to focus on today. But there are other ways, and if I look at this one up here, you can actually create a table. You can put that table directly into EEPROM, and if you say table, give it a name, and then this thing called store data, it will put it directly into memory. It's a very simple way of storing data. So if you have a table of the values 1, 2, 3, 4, 5, 6, that's this red block here, it will put it into the EEPROM memory. And it will just do that automatically. It's very simple. But more recently, and I think as a result of one of my French colleagues, one of the French customers here, they wanted to be able to write directly into into EEPROM without the table, and you can actually do that with the suffix EEPROM and the end EEPROM command, and it will then just write it out at a particular location in EEPROM. And if you wanted the values of 1 to 6, it will put it in at address 20 or hexadecimal 20. But we're going to focus on the functions of EPWrite and EPRead. So what we're going to do is we're going to write and read via a terminal. We're going to use PPS to select the USART port. We're going to write some values, read some values, and we're going to see the results. Then we can look at that via a programming interface. We can look at that, the values have been written, and we can see the results. So there's two ways of checking this. We can actually read and write and put it on our own terminal, but we're actually going to use in the second step a programming piece of software. Okay, let's go to some code and get started. So this is GC code. I'm just going to shut the code browser, and then I'm just going to zoom in so we can see it. And so essentially, there's a whole lesson here, but what we're doing here, we've selected our chip. That's the 16Q20. That's the one we're focusing on. These are the constants to set up the serial. We've seen those before. And then this is the PPS component, and you can use PPS tool to select port RB7, and that will then set up the serial. And essentially, I've got a little diagram here, and this relates to all the switches and then the potentiometers on the serial port connected to this particular machine. And we've seen these constants before, and these constants define our architecture. And here it is. Here's the program. We have a loop that is forever, do forever, and it actually just waits for a button press. And we have some serial commands. We've seen the serial before, and this will put it on the screen for us. So if I actually bring up a terminal, we can have a look what it's going to look like, and that might ease things. Here we go. What we're going to do, we're going to see it on the screen like this. It's going to put a string up, and then it's going to put some values on the screen. I'm just going to move things around so we can see it better. And it's actually going to put it in a little matrix, and it says at address 0, it's going to put the value FE or 255, 254, 253, and it will go through down to 0. And it will put a string out called end of EEPROM program and display, which is great. So that's what we're going to be doing. And how do we go about doing that? We go back to our source, and there's a little for next loop. For next loop uses that constant called chip EEPROM. So it says from 0 to chip EEPROM, which we know is 256 minus 1. Therefore, it's going to loop through 255, and it's going to format it and put it on the screen. You can see all that. But what it's actually going to do is actually going to write out something called out data, and it's just going to deduct that from 255, and all it's going to do therefore is it's going to write 255, 254, 253 in hexadecimal. And how is it going to do that? Using this method. And this method is extremely simple. EPWrite, the address. Remember, the first one is 0, so for next loop. The next one is 1 through to 255. And it's going to put in the out data. And we know the out data is the inverse of that, 255, 254, etc. I just clear the results. I've got a variable called inData, and I'm going to read it back in, with EPRead, read the EEPROM address, and put it in inData. Now you might say, why did I set that to 0? That is a redundant. Well, if you set that to some strange value, which is good, you should do that, then at least you know it's reading it back. It's actually been a very physical write into the variable called inData. And then the rest of this, it shows it on the screen. And if there's been an error, it will put a dash in the program. Let's look at programming that. I'm going to press function key F5 inside of the GC code compiler, and then I'm going to come out to my terminal. I'm just going to clear that down, make that window a bit bigger, shuffle that around whilst it's programming it, and it's just programmed it now. It's done it. It's done it as fast as that. Let's just get rid of that screen there so we can see the whole thing. It's actually put in 55 through to zeros. And how do we know it's done that? Well, as I said, we can look at the programming interface. If I bring in a PICKit2 interface, here we go, a PICKit2 interface here. I'll zoom out slightly so we can see it. And I've got the chip selected already, and I'm just going to select the EEPROM data in this user interface here. I must have one selected, that's correct. I want to have EEPROM selected. I'm just going to read that in. And it says in this bottom dialog box, 255 through to 00, which is what it said. Now, you might not believe me. So what we can do, we can go back into our code and we can say, give me some random numbers, or always give me some, change it to random numbers. Look, program it. And in our program here, in our terminal, we will see random numbers appear. Looks like random numbers to me. And then if we go into our PICKit2 interface and read that in, we get the same number set. 2DFF. Now remember, back in the, I wonder if it's the same actually each time. Let's have a look. No, because each time it runs, it's running a new set of random numbers. So you're going to get different data, but it's very simple to write. And if I just change that there in my source code to 55, write that out. And in a moment, we'll see 55 come up on the terminal, and that's a good test. And we can see the 55s. We read it in the PICKitPlus interface, and there, oh, there's one there. Oh, I know why. Timing. That's interesting. That's called, that's a timing issue. Turn the power off. Read it. Okay, the issue there is because it was bouncing on the power, and it was erasing the chip in the few seconds it had, the milliseconds it had. And by turning the power off and reading it in, it's actually not rerunning the whole program. Okay, there we go. We got EPWrites, and as I said before, there are other methods of doing it, but it's extremely simple. So what I wanted to show you was this method here, one of the 4 ways that we've got, and you can play with the others in your as you see fit. So that's EEPROM showing values on the terminal and some constants that are available to you. And the next video will be I2C, and we'll discover some I2C devices. Be great fun. And then we'll move on to GLCDs.